Right. And we're going to talk about infinite computing. It needs a little bit of introduction. I always talk about we're in the era of infinite computing in general, which means we are not in the finite computing anymore. Right? So now we're in the state where the cloud provides infinite compute. And the interesting trend that we're seeing right now is that companies are purchasing more and more of that infinite computing from both the public cloud and the hybrid cloud, and on-premise. Companies have both some interesting offerings to things on-premise. But the other interesting thing is we see this diversity of compute all of a sudden.
For me, it goes back to some of those basic technologies, right? And for so long, Intel was sometimes as much as 36 months ahead of the competition. Mm-hmm. When you had that leveling of the playing field, when there was actually more diversity, more competition in that basic underpinning technology, that admitted more ingenuity, more players, more diversity. Now, as we head out and we look, and we might just be about 2 years left in the second era of Moore's law scaling, and whether or not we'll get to 3D transistors for logic as we have for memory, that's an if, not a when. Right. And so now understanding how will we now pull in this heterogeneous computing world where it's no longer just, am I going to have this x86 core or that x86 core? It's understanding even more beyond CMOS, right? How am I going to harness neuromorphic, quantum, analog, and this diversity of purpose-built precision semiconductors? How am I going to harness all of that? And also, that when just about the year where maybe 1 byte in 4 that the enterprise cares about will be in a data center, then how do I admit all of those bytes? How do I admit all of that information, reason over it in a time that matters, get into an insight, and then turn insight into action? Edge, cloud, core, exascale.
One of the big benefits of cloud computing is you're purchasing everything as a service. You don't really care what it's running on. Yep. The enterprise historically doesn't move very quickly, and when they kind of wed themselves to a platform, could have been historically very hard for them to move. They've gone and they've purpose-built these applications, or they've bought these application licenses, and they don't necessarily move around very quickly. Now we're talking about buying something as a service, and under the covers, is it running Intel, AMD, or is it running some other platform? Who cares? It doesn't matter. Yeah, and not everybody is running a kind of a SaaS service, right? So we have customers who are running in the cloud. They care what the platform is, and they have software written for that particular platform, or more likely they're just unwilling to change because this is their corporate architecture and they've been using it for 20 years and they're really slow to change. That's often the reason.
We have to figure out what is it going to take for us to be able to pull together this precision ensemble of devices, whether that is inside of an individual package that's going underneath the hood of an autonomous vehicle, or it is at that exascale data center. We need to understand how we economically admit heterogeneous compute into the enterprise.
But you're right. All workloads are not the same. You're not going to do Bitcoin mining on a Intel platform, right? And so some workloads run better. Some customers also have different requirements. Some are going to be more conscious about cost. Some are going to be more conscious about performance. So it really depends on what their needs are. Mm-hmm. And I suspect, we don't have it yet, so I don't know, but I suspect that not everything is going to be the same, right? The pricing is going to be different, and that's going to somewhat drive customer behavior on what's important to them.
When we can actually liberate, and you can innovate with the agility of a consumption model, and then that frees me to introduce new technologies and new ways of tackling a problem. Actually, I can innovate faster too, and I think that's also what you're seeing. Yeah, we'll circle on AI and machine learning, but then there's the other one, which is massive data analytics, and for us, the last piece is simulation and modeling at the exascale. So in the middle of that intersectionality, today that's where we see science, and I think tomorrow that's where you'll see science and arts and industry and enterprise. All of them wanted to occupy that really intelligent space where massive data analytics, machine learning, AI, and simulation modeling all come together.
But cloud enables you to have more of these things. It's funny because we always say cloud is all about standardization. At least we like to tell people it's about standardization. That means no, we don't have that feature that we want. We want you to standardize on something else. But I think what people are doing is, or the opportunity that it gives you the opportunity to create all these different platforms, let's say, and and you can make them available to this huge audience. You don't have to try and sell them discreetly to everybody. And so I think cloud makes it easier to offer more choice. Quantum computing's out there. It's something that's coming along. It's also something that everybody is worried about, making sure that they're able to operate, because it actually changes the rules, right? There's right now rules that say your data is safe because it would take, 10,000 years to brute force decrypt it, and now you can't do that anymore. But it will come along and it will probably pop up as a parallel thing, and it might have special applications at first. The database, something general purpose like database might be a ways away from there, but who knows? Or ever, yeah. I mean, we'll see how it rolls out, but I think it'll probably start out with little niche applications.
It's the question of precision, right?
Yeah.
When it offers advantage and the advantage offsets the switching costs, people will naturally adopt it, right? And I think for me, we'll say, people are enamored with quantum. There's huge quantum FOMO because people see it as this really new, wow, I've participated on the consumption side of the IT economy for the last 40 years. I'd love to be on the supply side. That'd be a nice place to be.
Yeah.
So that's very attractive, but there's sort of that question is like when, and there's just no good way to answer that right now. And that's part of my day job is to understand how do we integrate not just quantum, neuromorphic, analog, memory-driven, all of this increasing diversity. And we just had a review of AI hardware. That slide had like 6 points on it because there are literally 100 companies out there experimenting with AI-specific hardware. Right. Now the problem is, back to your notion of standards, what we can't have is have all 100 of those companies have a different way to do just about everything, right? Because that fails on the productivity integration side. Even if we solve the physical integration, well, this one needs liquid helium, this one needs ultra cold, and all. So we'll solve the physical problem, we'll solve the cyber physical system. How do we pump that much data in and out of these things? And then we have to solve the productivity. And I think that's probably part of what we're working on. So,
we have to be able to deliver them in a cost-effective manner too. Yeah. I mean, if you come up with something that requires that people can hand build it for you to run it, even if it's in a cloud environment. Cloud environments don't work by people running down the hallway with screwdrivers and soldering irons, right? It's all about standardization. It's all about being able to deploy at scale. Yep. And so there will be standardization of some sort.